Week 20, day 1, we started off class by actually double checking to make sure that students have finished up their models from last week. So a quick gander back, not a word, to week 19, day 2. So go ahead and scroll down in your Google Classroom if you have not completed this. This is that final check-in to see what we have figured out during our Mr. Bean learning opportunities. So if you haven't finished that, go ahead and do that. While this was happening, if students had already finished, a couple of other opportunities were presented to go and play around with some simulations, to go and watch some videos. You can actually check those out in our other links for today, as well as in the extensions in this week's Week at a Glance, if you want to take a look at those. But outside of this pretty quick lesson today, in which we are thinking about color and the ways that color is perceived by humans. Now, you may or may not remember this from when it blew up the internet several years ago, but what colors do we see in this dress? It turns out that some people see the colors blue and black, some people see the colors gold and white, or gold and cream. And while this created a huge divide on the internet and a certain unfortunate amount of name calling, ultimately both are very valid perspectives because of the way that our human eyes have developed. If you don't see both, just seeing this with a greater or a lesser saturation, a greater or lesser brightness, we can see that emphasis going on there. But a lot of it actually has to do with sunlight and how our human eye has evolved over time in order to detect color. Now, on our planet, what is the primary source of light? We have sun. And as humans, what has our primary source of light for viewing as we interact with the world been? That same sun. So it turns out that, as you have probably noticed, during certain times of day, the lighting can make things look different colors, and our brain can actually kind of color adjust for that. I'll pull up a couple of quick images and add them to this for example. So as we look at different images at different times of day, things like the Taj Mahal, interestingly enough, if it's full daylight, it might look one color contrasted with a full moon, contrasted with a rising or a setting sun. All of these different lighting settings lead to a different perception of color, really. Looking anywhere from more of a bluish color to more of a yellow or a brown in these to almost a pure white. All of this has to do with that light's angle and everything, but what's interesting is our brain tries to adjust for that, because we know that even though it looks blue here, we tend to know, oh, well, in this night setting, this must be a white object, or in this brightening day setting, oh, this must be a white object, not the brown or the orangish yellow color it shows up to be now. Same thing holds true for when we look at water, right? It looks very blue down through purple or red, or even green depending on the lighting and the time of day. But we actually know that water, especially if looking at it in a container of some sort outside of the ocean, is typically a clear colorless liquid. We have different colors that can be used in printers to blend and create the colors that we perceive, and those are a little bit different, interestingly, than the ones we might use if we're in an art class, where you know that you can mix blue and red to get the color purple, or you can mix blue and yellow to get the color green. But all of these have to do with the same properties of color, which are that light is absorbed and light is reflected. And when light is absorbed into an object, it will suck in, but those colors that are reflected off are what our eyes tend to see, even on black objects like this, which tend to absorb more light than their white counterparts. So just more to experiment and play and run around. Students were presented this color simulation. And it's easy to jump in and play with it at a superficial level and go, okay, well, that's okay. But there are a lot more levels of depth that we can do if we're trying to explore from this lens of how is it that color is created and how is it that color is viewed in my eyes. Again, that simple level, changing the color of the light itself immediately changes the color that we perceive. And if we're looking at that particle nature of light, of course, that color is going to come to our eyes directly. But most light doesn't come in the singular bold color. Usually it's a mixture. It's white light, but that is comprised of all of those colors of the rainbow. That can be filtered out if we choose to. How does the color of the filter affect what our brain perceives? And again, when we're talking about a filter, we could be referring to a pair of sunglasses. We could be referring to the tinting on a window of a car or of a house. You can also explore and look with different specific compositions of light, these primary colors of green, red, and blue. How do they mix differently? How do they impact the colors that we are able to see when the light is varying strengths? If the light is quite weak in all three colors versus a medium strength in all three colors, much of a great color, versus full strength in all three of these colors, how does this impact the way that we are perceiving the world around us? Anyway, it's just an interesting little thing to play around with. And while we're not getting too deep into the discussions of how does your brain see, again, those are some of those extensions that are available in the week at a glance. Really interesting stuff to learn a little bit more about what's going on there. And that week at a glance can be found pretty easily in your classwork tab. If you're interested in it, got some neat stuff there. Anyway, I'll leave you to your exploration, because at this time what you would be best suited to do is to go and open up that color simulation, do some of your playing around. If you have some extra time, open up that week at a glance, check out those optional extensions at the bottom. The bottom one being the first one being about this black color, this Vanta black, or this Muso black, or any variations of these different colors that really reflect almost no light, even though this one here that I'm showing reflects a ton of light. And the second set of links down below about the vision element itself. A reading on how glasses help you out, or a video on how vision is helping, or how vision happens in general.